Hello and welcome back to another LeetCode easy problem. I have not tried this one before and we're going to try to solve this one as fast as possible. So Mary, I'm going to be a little bit less thorough going through the example as I do in the other videos where we focus on practicing for interviews. This is really for practicing a little bit of speed. So yeah, let's see. So 3427, sum of variable length subarrays. You're given an integer array nums of size n for each index I, where I is pointing into the array. Define a subarray from start to I, where start is the maximum of 0 and I minus the value at position I. Return the total sum of all the elements from the subarray defined for each index in the array. So, okay, so that's kind of start. From start to I, okay. So basically, if we have like an array that contains these, okay, let's go through the example just to make it clear. At least one value in them, in that nums array. So if we have this array, for I equals 0, we have the following scenario. So we take the nums value at 0, subtract it from I, and then we take the minimum. So the start value is actually 0. So from 0 to 0, so inclusive. So that's 2. Now here we take index I1, now the value is 3. So we have 1 minus 3 and the maximum is 0. So we start from 0 and we go to 2i up to I. So the sum is 5. Next, I is pointing, I has the value 2 and nums at index 2 has the value 1. So we have 2 minus 1. So we start from 3. Interesting. Okay, cool. So this can be done, if you compute the prefix sums of an array, we could do that. Then it would be an O of n time to compute the prefix sums in O of n space. But then if we actually perform the calculation for all the subarrays, it would be actually an O of 1 operation. So that would speed things up. Otherwise, we'd have an O of n squared solution where we need to iterate. We'll actually do all the iterations. So maybe let's just implement the iteration first. So the suboptimal solution. So it's O of n squared time and O of n space, because we need to wait. Oh no, we just need to return the total sum. So it's O of 1 space for that. So result is 0. We're going to return the result at the end. What am I doing? Return result. Right. So now all we do is for I in range len nums. We do exactly what they tell us we should do in the problem. And now we compute the subarray sum. So and so we have to compute the starting index first. Start is, well, max between 0 and I minus nums at position I, right? Right. So now the result is, well, we increment our result by the sum of the elements between nums start and I inclusive, I plus 1. And I think that's pretty much it. So let's run this. Invalid syntax. What did I do? Start, we're closing start, and then the sum of nums from start position. Oh, there's a 1 missing here. Typo. All right. Yeah, so that solves that problem. Yeah, let's make it more interesting. Let's do the same thing with the prefix sum and offer a different alternative. And that's also something you would try to do in an interview, right? You'd have one solution, then you would optimize it. But we're going to optimize it in a way so that we trade off the space, time for space, right? Here we have constant space, but we'll end up with linear space now. So for that, we have to compute the prefix sums of the array. And for that, all we need to do, well, we need to iterate through all of the numbers. And like so. And the first prefix sum is going to be 0. That's basically out of the array. And then all we do is we just add append, and we do prefix sums, well, the last. And we're just going to add nums at position position I. So that'll give us the prefix sum. So in this example, we would have 0, 2, 5, and 6 would be in our prefix sum array. Now, the way to compute to replace this O of n operation here, this is O of n. This, because here we're iterating over all of these elements and nums. So to compute that, all we need to do is, well, we have to compute the starting index. And now when we do the result, all we need to do is we need to take the prefix sum of our start, well, actually of I up to I. And because we have the 0, the leading 0, we have to, I think, add 1. But we also have to subtract the prefix sum up to the start position. So that's the trick with the prefix sum. Start plus 1. I think that there's probably an off by 1 error in here, but let's see. I'm willing to take my chances on this one. Wrong answer. We got 4 and 5, so maybe we subtracted 1 too many. Right, yeah, so that was the off by 1 error. And let's submit it. And there you go. So there are 2 approaches, and that we implemented in a very fast way. And obviously we're going to make small mistakes along the way, but that doesn't matter.